In this experiment, we are going to apply the two-factor ANOVA technique to test the relationship between two factors of interest with three levels to choose the type of materials that will cover the battery. To determine if the battery lifetime for a dispositive is affected depending on the material used and the temperature exposed to and to determine if there is significant interaction between these two variables. Variable definitions. The dependent variable is the battery life, and the independent variable is the temperature and the type of material. Objective. The objective is to determine if the temperature of material affects the difference in battery lifetime of each material.
The methodology is as follows. First, we have to do the test selection. We select the two-factor ANOVA technique because we want to test the relationship between two factors of interest with three levels. The second step is the hypothesis. H0 is that all means are equal for all factors, and H alternative is that at least one pair of levels is different for one of the factors. For steps 3 and 4, we are using R. First, we need to get the data. We need to input the data from Excel and a table. That's the command get WD to have the direction from where the data is coming. Then we need to set that direction so that the data can be input. We are naming the table data so that we know that data is containing all the information that we are going to use. We use the header and put it as true because in our table we have headlines that are temperature, material, and sample. Now that we have the information in our table, we need to establish the model so we can do the ANOVA table. In the ANOVA table, we are getting the sum of squares and the degrees of freedom, as well as the information within the groups and between the groups. Now that we have the ANOVA table, we need to ask for the summary. In the summary, we are getting the p-value, and we can see that in the temperature, that is less than 5% of alpha, and the material is also less than the 5% of alpha. But in the temperature and the material, the relationship between the two, the number is 0.52, that is greater than alpha. Because we notice that there is no interaction between the two samples, we are going to use the main effect plots. That's why we need to upload the library gplots so that we can plot the mains. This plot shows the relationship between the sample and the material. So we can see that the material number 3 is the highest, so is the best to choose. Now we are going to plot the sample compared with the temperature to see which is the best resistance temperature. Now in this plot we can see that the temperature is at its highest level at 15 degrees.
So now we can conclude that the temperature alone does affect the battery lifetime as well as the difference in the material used each on their own. However, in the interaction between the temperature and the material does not affect the battery lifetime. The best material to use cover the battery would be the material number 3.
For step number 6, which is the validation of the model, we first need to upload the library NOR test. So we can do the Anderson-Darling normality test, which is going to give us the value of the p-value. And as we can see, since the p-value is greater than alpha in the Anderson test, it means we cannot reject H0. That means that the data adjusts to a normal distribution. To confirm the Anderson test, we need to plot model 1. We are going to get a residuals versus fitted plot and a QQ plot. The first one, the residuals versus fitted plot, shows us that the variance is not constant because there is not a horizontal line that confirms the constant value of the variance. Then in the QQ plot, we see that the dots are near the line. So that confirms the Anderson test, normality test. So this was the two-factor ANOVA test.